Alright, so what you see here is a basic transformer. The upper part would be the high voltage. The lower part with X1, X2, X3 is going to be your low voltage and is depicting a center tap. This particular transformer we spec'd out at 25 kVA, so that's about 104 amps continuous across the X1 to X3 terminals. Here I've placed a 120 volt load on terminals X1 and X2. So this is total capacity of this transformer is 25 kVA. So since we're only using half the transformer, we only have 12.5 kVA that we can pull. That means any load, any 120 volt load over 50 amps will force this transformer into an overload condition. If you were to take a clamp-on amp probe and you would measure the amps at terminals X1, which is actually line 1 inside your breaker panel, you will see that there's a 5 amp load. If you move that same amp probe over to the neutral, going outside up your service into the transformer, you will see that you have 5 amps. Now moving the amp probe over to X3, you will see no amps, and that's because there is no load in this drawing on the X3 terminal or L2. Here I've added a second 120 volt load in between the X2 and X3 terminals, X2 being neutral, X3 being line 2. Now this is quite interesting because now we have 220 volt loads that are technically connected together in series across a 240 volt coil. So if we take our amp probe and we go to X1, we will see 5 amps going across that X1 terminal. If we go and we move the amp probe over to X2, it should be 0. In real world conditions, you might see 1 amp or so there. If we move that amp probe over to X3, we also see 5 amps. And that's because we have our two loads connected in series. So you got 120 volts on the left, 120 volts on the right. You add those two together, and it gives you a total capacity of 240 volts. The transformer is outputting 240 volts, so your total amps that the transformer sees is 5 amps. Here I've removed the 220 volt loads from both X1 and X3 to neutrals, and I have placed a 240 volt load across X1 to X3. To the transformer and the electrical system, this load appears exactly the same as the 220 volt loads. So if we take our amp probe and we go to X1, we'll read 5 amps. If we take our amp probe and go to X2, we will read 0 amps. As you can see, nothing's connected to it. And if we take our amp probe and move it over to X3, we will read 5 amps. Now I've added one of the 120 loads back. This is very common for what you'll see in a house. The 240 load that's running across X1 to X3, that could be a water heater that's running. The 110 volt load that's running in between X1 and X2, that could be the light in your bedroom that's running. So right now, we have two things that's going on. The 120 volt load between X1 and X2 is placing a 5 amp load on that coil of the transformer. The 240 volt load that's running in between X1 and X3 is placing a 5 amp load on each half of the transformer. So if we take a multimeter, or take an amp probe, and we connect it to X1, we will see 10 amps of current on X1. If we move our amp probe over to X2, we will see 5 amps of current on X2. And if we move our amp probe over to X3, we will see 5 amps. And that is because the load is being divided equally across those coils in that order. Alright, I've added the second 120 volt load back to the system now. So the transformer in this configuration sees a total of one 240 volt load that is pulling 10 amps. Alright, and this is no difference from our first drawing. So we have the 120 volt load, 120 volt load equals 240 volts. And if we go across terminals X1, we will see 10 amps. If we hook on to terminal X2, we will see 0 amps. And if we hook on to terminal X3, we will see 10 amps. So in this configuration, we could load the transformer up to a total of 25 kVA. At no point do you ever add X1 and X3 together for your total amperage. That's impossible. It's not how a transformer works. Each load is spread across a coil. This is a transformer calculator from Alpha Transformers. They actually make some power line transformers and some stuff for regular light commercial duty. But what I'm going to show you here is if you have 240 volts, and this is from the manufacturer, 240 volt service, and you're going to have 200 amps continuous on that service, then you should have a 48 kVA transformer. Alright, so you're going to have more than one 200 amp service, or more than one service, house connected to this. Let's say you got a 100 amp service and you have a 200 amp service, so that's going to be still, the voltage is going to be 240 volts, and you're going to have 300 amps now, and you hit calculate, so you should have 72 kVA. Now when you're sizing a transformer, at least the power companies, they actually allow for some amount of overrating. So if I was in this predicament, I would probably allow a 25%, maybe at most a 50% overrating, say for an hour or 2 hours. But you should never run anything at 200% overrated for that long. This calculator works in a couple of different ways. So let's say the service that in this video has a 25 kVA transformer, and we're at 240 volts. So when I'm going to hit calculate here, you're going to see that a 25 kVA transformer is only rated for 104 amps continuous.